Hi everyone, this is a video lesson on when we find Pythagoras calculations inside circles. There's a quick starter here first, so we'll complete that and then come back on for the answers, please. Right, question 1 is quite similar to the questions that we did yesterday. So we have got, first of all, I would spot that I have a right angle in the bottom right hand side of the right angle triangle on the left hand side of the shape. Additionally, I also have an angle of 23 degrees beside the right angle. That is because those two sides are both radii within the circle, which means the angles are the same size as well. So if I do 180, take 23, take the other 23, I will find out the angle on the right hand side of the line at the centre of the circle. So that will give me in here 134 degrees. If I do 180, take 134, I will get 46, which will give me the angle in the right angle triangle on the left hand side. Therefore, to find the missing angle, down the bottom left, 180, take 90, take 46. So we have an angle of 44 down the bottom there. So that was putting together both the tangent calculations and also the calculations involving isosceles triangles within circles. Question 2, we are going to have to apply Pythagoras' theorem to this triangle to find out the side x. So Pythagoras' theorem, we use the letters A, B and C, and making sure that C is our longest side, then we can say that C squared is equal to A squared plus B squared. We've done this in starters previously, and we've had a whole topic on Pythagoras' theorem as well. So hopefully this is jogging some of your memory. Now, C squared here is 24 squared. A we don't know, so we could say that's x squared, and then B squared has to be 5 squared. I would like to try and get x squared on its own, so I'm going to take away 5 squared from both sides. That will give me 24 squared, take away 5 squared equals x squared. So x squared then is equal to whatever that calculation brings out, 24 squared, take 5 squared, pop that in the calculator, gives me 551. X is then the square root of 551. If we're going from x squared down to x, then we square root the number that x squared is equal to, giving me 23.5 centimetres to 1 decimal place. Okay. Now we will need our facts about tangents and circles, but also about how to complete Pythagoras' theorem on right angle triangles today. Right, question 1 here. So we can see that there is a right angle triangle within this circle, and that is because our triangle here is those 3 lines. Since each of the lines labelled with 12 and 9 come from either side of the diameter and meet on the circumference, they create a right angle up the top of the triangle. Now in this question I am asked to calculate the size of the diameter. The diameter in this question is along that line there. So if I've got a right angled triangle and I know 2 sides, I can find the other one using Pythagoras' theorem. So we'll label the diameter as C. That has to be the largest side as it's across from the right angle. A and B are the other 2 sides. It doesn't matter which way round you put A and B. So we're using the formula C squared equals A squared plus B squared. C squared, we don't know what that is, so let's leave that there just now. A is 12, that's 12 squared plus 9 squared. Pop that into your calculator. 12 squared plus 9 squared is 225. Therefore C is the square root of 225. Square root of that answer gives us 15 metres. So the diameter in this case has to be 15 metres. I'm not asked anything about the angles in the triangle, but I have to use the angle facts to identify where the right angle is, and therefore the ability to use Pythagoras' theorem. The next example here, we are looking to find the radius of the circle. So in this circle diagram, we have got a right angled triangle on the right hand side. The line which has 14 attached to it is a tangent to the circle, and it meets the radius at a right angle. Okay, so we need to know the words, particularly the word radius here. We're looking for the centre of the circle to the outside of the circle. So the line, this line here is the one we are trying to find. Now I should really have marked on this 14 is actually just the length of the triangle base. It's not the length of the whole tangent. So the calculations we have to do then, well, we're trying to find the radius, the side of the triangle that I've marked in with a red line. C has to be the 20 since that's across from the right angle, and A and B we can label as any of the other two sides. So in this case I'm trying to find the size of B. I still use C squared equals A squared plus B squared. 20 squared goes in place of C, 14 squared goes in place of A, and B squared is there. Take away 14 squared from each side, so 20 squared take away 14 squared equals B squared. This is the same as the one that I did in the starter, where we're finding a smaller side. So B squared is 20 squared take away 14 squared. Notice with the last example, I am adding them together because I'm trying to find the largest side. With this next example, I am subtracting them because I'm trying to find a smaller side. So 20 squared take away 14 squared, and the calculator gives an answer of 204. B is the square root of 204 then. So B, which is in fact the radius here, is 14.3 centimetres to 1 decimal place. Now if we were asked to extend this question and we were asked to say how long or what is the length of the diameter, then we know the diameter is just double the radius, so we would have to times that by 2. We're not asked for the diameter though, so we don't have to do that calculation. When you're doing these questions, just read the question very carefully and see what it's asking you to do. It might not be asking you to do what you think it is at the very beginning. Right, so the questions in the worksheet today are going to look similar to this one here. They'll have a little bit of blurb at the left-hand side and then the diagram on the right. A lot of the diagrams here are not annotated, so you'll have to write on your lengths and so on. So copying the diagram out and writing on your lengths will be really useful to you. So what am I told then? So I'm told here that both circles have a centre M and N. Okay, that's marked on. Both have a radius of 11. So let's mark on all of the 11s. That solid line here, MP and NQ, but also I have 11 down the bottom there along this line, that's 11, and also along that other dotted line. They are both 11 each, as they are both radius of each of the circles. So M to the middle of the two circles is a radius, and N to the side of the two circles as well is also a radius. So that's all parts of 11. Now, what shape is MQ or PQNM? Well, for part A, that's an easy one. It's a rectangle. That's not really a difficult question there. Part B is where you've got to do some of the calculations. In part B, we're looking to calculate the diagonal MQ. That's not drawn on the triangle, so if I draw that in, it'll be that line there. Now, the triangle then is in fact this triangle here. There's a right angle down the bottom there. Okay, since we know that the these two lines here are radii. They're right beside each other, and we're drawing a line between the two centres. So that has to be a straight line there. The line along the right-hand side of the triangle is a radius. That has to be a straight line as well. Now we also know that up the top here is the same triangle. That's because there are 4 right angles within this shape, which is how we also know that it is a rectangle. So we're really using, essentially not really, the tangent questions, but we are using that to help us with the final answer. Okay, so when completing this question, then I am going to draw out this right angled triangle over at the side. Mark on 11, centimetres for the radius there. The line down the bottom is 2 radii together, so that has to be 22 centimetres. In the diagonal, I'm trying to find the length, the diagonal length, so that's that diagonal one in the triangle as well. Label that one as C. A and B can be either of your other 2 triangles, your other 2 sides. So C squared equals A squared plus B squared. A is 22, 22 squared plus 11 squared. Pop that calculation into the calculator. If you have to, if you're using your phone, you might have to square these numbers first of all and then put them in the calculator. Okay, so 22 squared, find out what that is, 11 squared, find out what that is, and add them together. Okay, we end up with 605 for that then. When we square root, we get 24.6 centimetres to 1 decimal place. Okay, unless the question tells you to round to a particular number of decimal places, just round to 1 decimal place when you're doing the answers. Okay, so there'll be a worksheet on the Teams page and questions for you to complete. I would like you to go and do that just now, please, and then come back on and then ask any questions if you need to. Okay, the next lot of questions will be for Friday's lesson. Okay, thank you.